Hi everyone. So this video will be about forces and motion. This can help you to prepare for a physics exam. So let's start. So first that we can actually talk about all of these, we need to talk about forces. So what can we see here? So we can see two cats, and what are they trying to do? They're trying to drink milk. So what happened? One cat was pulling the this part with the milk, and then, for example, when we observe here, we also have two cats, but in this case one cat is pushing another cat. So why I'm showing you here cats, and why I'm showing you how one cat is pushing another one, and how this cat on the left side is actually trying to pull this bowl with the milk. So because in physics, the simple form how you can define what force is that you just say that force is like some kind of push or pull. Um, this push or pull basically will result in some kind of interaction with another object. In this case, when cat was using her force, um, in this case when she pulled the bowl with the milk, so this was one kind of interaction with the object. And here this cat, when was pushing this another cat, is also some kind of interaction with, in this case, another cat. Basically the point of the story here is that what actually force is doing, force can change position. So in this case it's changing position. It can change the speed, so in this case this cat speed up moving down the stairs, or it can change the state of object. Um, as we will talk about forces, we also need to mention that we have different type of forces. So for example, what we can see here, so let's say we have some kind of paper and rock, and you have two different conditions. So in this on the left side you have like some space with air, and here you have the vacuum, or it's meaning without air. So what you can observe that definitely where is a vacuum, when you observe the paper and rock, they will fall at the same time. Um, while where is air, the rock will be much faster than the paper. So basically what we are talking about here is that air is causing the different speed or different motion, how this paper or rock will move down. Why we are talking about this, or why I'm showing you this, because in this case this type of force that is slowing down, in this case more is slowing down the paper, is called air resistance. So paper is resisting to air to be pulled down. In this case, these objects here, I mean paper and rock, are in some kind of, we say, in contact with the force. So in this case, they have some kind of contact, they're touching each other. So physical contact, they're touching each other. Actually, how this air resistance will slow down the object. In second one, what we have here, we have magnet on the one side, magnet on the second side, and inside is the basically one substance that is made of um, iron, or can be something similar to this. So the point of the story is that these magnets are causing the change of the shape and movement of this substance inside. Um, why this is important? Because if you notice, this magnet is not physically touching the substance inside. So in this case, definitely there is no direct physical contact. So here we are talking about non-contact forces. So basically, the main context here is that you understand that we have, regarding type of forces, that you have contact and non-contact forces. So like we had here, contact force is basically forces that will need to have some kind of direct physical contact between two objects, like we had here between air and paper and rock. And non-contact forces are basically the ones that they don't need to have or they don't have physical contact with some substances. Examples are for contact forces, for example, air resistance, friction force, tension, etc. While non-contact forces are, for example, magnetic force, electrostatic force. Here you have one picture of one male. So the name of this guy here is Isaac Newton. Isaac Newton was a scientist. We will mention him here because he has some important role regarding forces. He was exploring the gravity and many other things. The next thing, what is important that you understand, what's the symbol for force. So as the name is force, so the symbol which we use to represent force, especially during different calculations, is the capital letter F. So this is really important. So everywhere where you see capital letter F, this is presenting force. Measuring unit of force is actually Newton, and symbol for Newton is the capital letter N. This is also important. This is the reason why Isaac Newton is actually here, because the measuring unit actually is given by using his name. Then we have one application here. So what you can use in this application is basically how you can control what will happen on left and right side. So for example, let's put one boy here, and let's say two girls here. So if you notice, the number change. So on the left side, the one boy will apply 50 newtons of force on this chart, and on the right side, these two girls will apply 100 Newton force on the right side. So they're pulling. So they will try to pull on this direction, and this one will try to pull on this direction. That you have only numbers, and that you know that they're pulling in opposite direction. What do you think, in which direction this chart will move? On left, on right? And if they even move, how much will be the resultant force? Resultant force is basically the force that will be subtracted using the left and the right force. So let's assume like this. Let's see what will happen. In this case, you have 50 newtons of force on the left side and 100 newton force on the right side. So definitely the right side is much stronger than the left side, so definitely the chart will move on the right side. How much actually force will be used to move on the right side, or the difference between forces on the left and the right side, is basically 50 newtons. How do you get this number? So if you know that 50 newtons was on the left, 100 newtons on the right, so 100 minus 50 gives you 50 newtons. This 50 newtons is basically, we call it sum of the forces, or more proper word is resultant force. Let's see what will happen if I put two boys on this side and two girls on this side. So in this case, they're applying the same amount of force, so 100 newtons on the left side and 100 newtons on the right side. What do you think, in which direction will they move, and what will be the resultant force? So if you notice here, the chart is not moving. Why the chart is not moving? Because the amount of force applied from the left and right side is the same, so 100 newtons, which is meaning that the resultant force in this case is 0. So that's the reason why they are not moving. Again, we can put, let's say, 3 guys here, and let's say 2 guys here. So in this case, we have 300 newtons on the left side force and 100 newtons on the right side. So what do you think in which direction they will move now? Definitely they will move on the left side. So why chart will move on the left side? Because there is more force. How much more force? So 300 minus 100, so the resultant force is 200 newtons. So 300 minus 100 gives you 200 newtons. Basically, this is when we are talking about balanced and unbalanced forces. So definitely in this case, when the chart is moving either on left or right depending on the amount of force, this is definitely called unbalanced force. When the resultant force is zero, which is meaning that the amount of force is equal on the left and the right side, then we are talking about balanced forces. The next one is friction force. Friction force, basically how it's applied and what actually is. Let's see this example. So you have some kind of box here. I will show you basically now the sum or resultant force is zero because nothing is applying any kind of force on this. So let's say that these guys start pushing. Object is still not moving. If you notice, here it says friction force 25 newtons, applied force 26 newtons. If you notice how arrows are pointing in which direction, you maybe notice now that the friction force is pointing in opposite direction than applied force. So until the amount of friction force is the same as amount of applied force, the object will not move. While amount of applied force becomes bigger than friction force, the object will start moving. So in our case, this guy needs to apply 127 newtons of force so that this object can actually start moving on the surface. In this case, 127 newtons applied force in opposite direction is basically friction force, and the amount of friction force in this case was 94 newtons, which is meaning actual or resultant force in this case is 33 newtons. How do you get 33? So you get that you do subtract 127 newtons minus 94. In this case, also what is important, the mass of the object, of course, which you are pushing on the surface, and we will mention on the next slide the different surfaces will cause the different type of, let's say, movement or amount of movement depending on this. What is here actually important, that friction force is a force that will act in opposite direction than of movement, which is meaning when you apply force on some object like we had here, the friction force will be in opposite direction. How does actually the surface affect the friction? If you notice this cat here, this cat is running more correctly, running on the grass, and it's actually doing pretty easy that, right? But when you observe this cat in the house where there is no grass, there is different type of material, more slippery one, let's say like that, this cat actually here has a little bit problems to run or even walk. So what's the difference here? If you know that the friction is force which is acting in opposite direction of movement, which is meaning basically friction is trying to slow you down. That we don't have friction, we will walk constantly. There will be nothing to slow you down that you can stop your movement. So regarding this cat, if you know that the friction is opposite direction of movement, that friction, the point of the friction is to slow down the object, and here is not so much the case because this cat has a problem. So definitely the smoother the surface, the lower is the friction force. The lower the friction force, the more slippery it is, so which is meaning that object will have more difficulties to, let's say, slow down. While where you have the rougher the surface area, like the grass, which is meaning the higher the friction force, the object will be able to much easier to slow down. So that's the whole story regarding the different surfaces and how they're affecting friction, or how the friction is affecting motion of different objects or people or animals. The next force is gravity. So gravity is basically non-contact force, which is meaning it doesn't need to be in physical contact with something. Why again is cat here, and why this guy is trying to walk on the moon? So the point of the story here is the gravity basically is the force that is trying to pull you down on this case is pulling down. Cat jumped, and the gravity is pulling down again cat on the floor. Why I put this cat and why I put this guy on the moon? Because it's not the same thing while you're walking on the planet Earth and while you're walking, let's say, on the moon or any other planet, because the amount of force that will pull you down is different on different planets. So one more time, basically gravity is invisible force, definitely is non-contact force that is actually pulling objects down. Then what do we have here? How we can actually calculate gravity. So we need to have some informations that we can actually calculate that. The symbol that we use for gravity, if you know that gravity is force, so definitely it will be capital letter F. But that you can actually recognize that we are talking about gravity, you'll use capital letter F and small g. This symbol will basically represent the gravity. Now that you can actually calculate that, you need to have two information. One of them is mass of the object. So mass we label with a small letter m, and measuring unit for mass is kilogram. The symbol is kg. The second thing that you need is gravitational field strength. The gravitational field strength we label with small g, and the measuring unit is Newton per kilogram. So basically this one is saying how much force you need to apply per 1 kilogram of body mass. Gravitational field strength is different on planet Earth, on the moon, or any other planet in the universe. So, which is meaning that mass of the object will be the same wherever you go, on any planet you go, but small g will change. In the end, if you have mass and gravitational field strength, you can easily calculate gravity. How you multiply mass with small g, and the number that you get is basically force, gravity force. On planet Earth, the small g, usually the number we round it up, so we use the number 10 newtons per kilogram. More correctly or more precise will be 9.81, 9.82, depends on which part of the planet Earth we are talking about. But usually you will see in different tasks that they are rounded up on 10 newtons per kilogram. Weight. So what actually weight is? Weight is, we can say that weight is basically part of the force. It is a force actually. Usually you are confused between weight and mass. So weight is not the same thing as a mass. So weight has the measuring unit Newton, while mass has a measuring unit kilogram. Mass is actually measured using a scale, while weight is used measuring Newton meter or dynamometer. So most of the time you're expressing your weight as a mass, which is incorrect. Especially, I mean, usually it's definitely is incorrect, but in physics you must understand that there is a huge difference between weight and a mass, and it's a huge mistake if you say that your weight is, for example, 100 kilograms. It's not. So if your mass is 100 kilograms, then your weight will be on planet Earth basically 1000 newtons. So if you notice, it's actually a huge difference. So how you can define what weight is? So we usually say that weight is like some kind of measure of force of gravity on different objects. Why we say that is a measure of force of gravity on an object? Like you have picture here, you have planet Earth and for example Moon. So on planet Earth, the gravity is, we set gravitational field strength approximately 10 newtons per kilogram, or 9.81. While on Moon is basically 1.62 approximately. So regarding that, different gravitational field strength will give you in the end different kind of weight. Regarding weight, the formula is how you are calculating weight is the same as for gravity. So again, you need to have mass of the object, which is in kilogram, times small g, which is gravitational field strength, which is different on different planets. So, and the only difference in this formula is that the weight, the symbol for weight is the WV, capital WV, while in gravity is Fg. Regarding gravity and weight, when you want to compare them, like on planet Earth, what's the difference? So if you have, let's say that this Earth here is a table and this astronaut is like a book on the table. So the foot that is touching the table, or the foot that is touching the planet Earth, is actually representing weight, how much force you're applying on that table, while gravity is coming from the middle point of the book, and the force is applied on the table. So application point of force is different in weight and gravity. So in weight is the part where the object is touching another object, while regarding gravity is like the middle point of the object which is applied on another surface. The next force is the buoyant force. So the buoyant force actually is connected with liquids, and why something is floating, sinking, or neither is floating, neither is sinking. So for example, when you observe here on the right part, you have small ball put in the water and big ball put in the water. One is sinking, one is floating. When you observe the small one sinks. Why? Something will push that small ball inside of the water until it goes down. This pushing force in our case is weight. So weight is pressing this ball down. In opposite direction will also act one force in the water. That force is called the buoyant force. So the buoyant force in this case will be smaller than the weight, so this is the reason why the object will sink. While when you observe this big ball here, the big ball is floating, which is meaning again you have force which is applied, try to push this ball in the water. That force is again weight. And you have force which is acting in opposite direction, which is the buoyant force. So if the buoyant force is bigger than weight, the object will float. So in this case, the bigger ball is actually will float because the buoyant force is bigger than weight force. If you have situation that buoyant force and the weight are the same, so the same amount, then this object will be like in the middle. It will not be either on the bottom and also it will not be on the top, so it will be like in the middle. Then we have one example of task how you should calculate something. For example, let's say that you have apple. This apple will have mass of 100 grams. What you need to calculate? Weight of that apple on the planet Earth. So always the first step is to take out all data that you have in this task. So the first data that you have that mass is 100 grams. If you notice, mass is in grams, and you know that in formula you need to use mass in kilogram. So when you get the mass in grams, definitely you need to convert that grams into kilograms. 1 kilogram has 1000 grams, so which is meaning when you are going from smaller to bigger unit, from grams to kilogram, you need to divide with 1000. So in our case, 100 grams gives you 0.1 kilogram. So you take out the first part, so you take out mass. So mass is 100 grams. The next step, what else do you have in the task? You have small g. So small g is 10 newtons per kilogram. Small g is gravitational field strength. So you write that down also. When you take out all informations you have, the next thing what you need to write down is what actually you need to calculate. So in our case, we need to calculate weight. So you need to remind yourself, what is the symbol for weight? So the WV. So you put WV question mark. So this is the thing that you need to calculate. So next step, you need to write the formula for weight. So formula for weight is mass times g, or gravitational field strength. So now you have all informations, you know what you need to find out, you write a formula, so the next step is put everything in the formula. So mass is 0.1 kilogram times 10 newtons per kilogram equals 1 newton. So answer is 1 newton. So an apple of mass of 100 grams will have weight 1 newton on the planet Earth. Then, for example, next question. Calculate the weight of a 30 kilogram dog. So one more time. First step, take out data you have. So you have 30 kilogram dog. You know that a kilogram is a measuring unit for mass. So 30 kilogram is actually mass. So symbol for mass is small letter m. So we are writing small letter m equals 30 kilogram. The next step, or the next thing that you have that small g is equal 10 newtons per kilogram. So you will write it down. G equals 10 newtons per kilogram. Then when you take out the old data, the next step, what we need to find out? We want to calculate the weight. Symbol for weight, WV. You put WV equal question mark. After that, you're writing a formula for WV. So WV equals mass times G. After that, you're putting everything in formula. So mass is 30 kilogram. You don't need to convert because it's already in kilograms. So 30 times 10 gives you 300 newtons. So actually 30 kilogram dog will have 300 newtons weight on the planet Earth. This is the answer. The next thing is we will mention elastic force, or how different forces can also affect not just how object will move, they can also affect how they can change shape. So like you can see here, either by stretching, compressing, so all these, or bending, all these things or combination of these things can affect how different forces can change the shape of different objects. Then here, for example, we will demonstrate the elastic force. As the name say, elastic force, so it will be related to materials that are elastic, which is meaning elastic is basically a property of material that can help them to either bend, either extend, either compress, etc. So in this case, what we will do, we will put, this is like one normal spring, similar to one that we had in our Newton meter in school, and we will put one that is like a opposite, let's say much bigger than this one. And what we will do, we will put this line is actually that we can measure the length of the spring, and you can actually do like this. Okay, so I will leave a ruler like this, and now we can apply, let's say 50 grams of weight. So in this case we need to wait that it's calm. Also we will observe what will happen. In this case, what is going on? It will move approximately at 60 centimeters, right? Let's see what will happen if we move this one to this one. I don't know why it doesn't want to. Okay, so if you notice, in this one, extension of the spring, when you apply some mass, it will be shorter than here. What's the point of the story? This, how strong is the spring, or here it says already, the spring constant. The bigger the spring constant in this case, not just in this case, in any case, so the bigger the spring constant, the less will spring extend, which is extend, word extend meaning increase in length. So like you can observe here, for example, it moves for approximately, let's do like this, it moves for 5 centimeters from original length, while this one moves approximately 11 centimeters. So it's a actually huge difference. It's a double. So in this case, definitely you can observe that spring constant, or how tough the spring is, or is it tough or not, or thick or not, will depend how much it can extend. Also, let's see what will happen if I add 100 grams on this spring. So we said 50 grams will extend for 11 centimeters. Let's see how much will be when I put 100 grams. So for 50 grams was 11, and for 100 grams is approximately 21. It's almost double. Let's see what will happen if I put, cannot put together, okay. If I put, let's say 250. So it will be approximately 50 centimeters. The point of the story, just that you see when you put on this one, that is not the same. So in this one it will be approximately extension of the spring 21. So less than this one on the left side. The point of the story, why we are observing this. There's one law that is called Hooke's law, named by Robert Hooke. This law says if you apply some force on the spring will extend. So in this case, this mass, this small 50, 100, we call them actually weight. It's not the force that we are using in physics. It's like weights that are used to either for when you're practicing something, or in this case when you're putting on the scale, like practicing, I mean, in everyday life. So the point of the story is that when you put some kind of force on the spring will extend. In this case, why saying that we put some amount of force, because when you hang this weight on the spring, this is pulled down by gravity. So if you calculate basically these 50 grams, when you convert it into kilograms, so which is meaning that you need to divide it with 1000, that will be basically 0.05 kilograms. And if you know the small g, let's round it up, it's 10 newtons per kilogram. So that will be basically 0.5 newtons of force applied on this spring. So if you apply 0.5 force on this spring, the spring will extend approximately, let's say, 10 centimeters. So the point of the story, this Hooke's law is saying, applying force on the spring will extend. The lower is the spring constant, so the smaller is the spring constant, the more the spring will extend, which is actually correct. If you observe, when you put here's large spring constant, so the spring extended less than the one that has actually lower spring constant. So all about this elastic force is basically regarding the spring constant and extension and applied force. The next step will be that you get the formula. So like we all already mentioned all of this, and I already explained the Hooke's law and how it is. The spring constant is basically just a measure that measure of stiffness of a material. Basically it will indicate how much force is needed to change the length of some material for 1 meter. The formula that we are using to calculate the Hooke's law or this elastic force is that you need to multiply spring constant with extension. So in our case, we know the experiment that we did slide before, we know that this force was 0.450 grams. It was 0.5 newtons, and the extension was 10 centimeters. So we will need to convert these centimeters into meters, and we will be able actually to calculate spring constant. How you can get the spring constant if you know the force? So our force was 0.5 newtons, extension was 10 centimeters, which is meaning that is 0.1 meter. So how you can actually calculate spring constant? So spring constant will be basically you will need to divide force with meters. So 0.1 divided by 0.5 divided by 0.1. So you can always play with these formulas. So sometimes you will need to calculate force. So then just multiply spring constant given in the task times extension. Sometimes you will need to calculate spring constant. Then you need to rearrange the formula, which is meaning if you need to calculate spring constant, then you need to divide force with extension. Maybe sometimes you will need to calculate extension, then you will need to divide force with spring constant. So these are the small tricks that you need to practice how to rearrange formulas when needed. What is here important? Again, elastic force, the symbol is capital letter F and small e, which is representing elastic force. The spring constant, the symbol is small k, and the measuring unit is Newton per meter, while extension is small e and the measuring unit is meter. In the end, we have few practice questions. So the first one, what is force? So the first slide we said force is basically push and pull. In this way we are changing either the direction, the shape of different objects. The second one, what is the symbol for force? So the symbol for force is the capital letter F. What is the measuring unit for force? So measuring unit for force is Newton, and the symbol is capital letter N. What do you know about Hooke's law? Write the formula. So we said the Hooke's law is saying that if you apply force on the spring, the spring will extend. If you double the force applied on the spring will extend for doubled amount. Formula is so F E equals K times E, which is meaning spring constant time extension. The next question, what is dynamometer? So dynamometer is a device used for measuring force, also sometimes you'll find on the internet Newton meter. What is the difference between balanced and unbalanced forces? So balanced forces is when you're acting on the object from left and right side, and the amount of force applied on the object on both sides is the same. So let's say 50 newtons on left side, 50 newtons on the right side. If the amount is same, then they are balanced. If you have more force either on the left or right side, then we call them unbalanced forces. What is friction? So friction is a force which is acting in opposite direction of movement. Then the next one. Yelena has mass 55 kilograms. What is her weight? If we are talking about planet Earth, so you need to use the formula mass times small g. Small g is gravitational field strength, and on planet Earth is 10 newtons per kilogram. So in this case, if Yelena has mass 55 kilograms times 10, this will be 550 newtons. So answer for 8A is 550 newtons. How much gravity acts on Yelena's body? So again, mass is 55 kilograms, small g is again 10 newtons per kilogram, so 55 times 10 is 550 newtons. So gravity is 550 newtons. What is the friction force between the box weighing 300 newtons and the floor? The friction factor between the box and the floor is 0.1. So regarding friction force, we didn't mention the formula. This will not be in the test, but this is for who would like to learn more. The friction factor doesn't have a measuring unit, and basically when you need to calculate here, you need to include the force that is pushing this body on the floor, and that is actually weight. So the weight is given in the task, which is 300 newtons times the friction factor. So 300 times 0.1 is 30 newtons. So in this task, we need to do some calculations. So a little bit more. So let's see first, what do we have? So we have that the weight of 10 decagrams is on the spring. We know that the spring constant is 100 newtons per meter. We know that we need to observe the picture, and we know that we need to calculate elastic force and weight. So let's go step by step. Let's first take out all data we have. So weight of 10 decagrams. So we are talking about mass. So mass is 10 decagrams. First, we need to convert these decagrams into kilograms. So we know that 1 decagram is basically 0.01 kilogram, which is meaning that when you're going from decagram to kilogram, you need to divide with 100. So in our case, when we divide 10 with 100, we are getting 0.1 kilogram. The next step is take out what else do we have. We have that the spring constant is 100 newtons per meter. So symbol for spring constant is small letter K. So K equals 100 newtons per meter. Then it says observe the picture below and calculate. Okay, let's observe, do we have some extra information here? So this is the length of the spring at the beginning, so E0. It was 10 centimeters. Then they put some weights and the spring extended and it was 12 centimeters. So actual extension was 2 centimeters. So we can write extension equals 2 centimeters. That's it, what we need from here. The next step, what we need to calculate. So elastic force and weight. Elastic force we label with a capital F, small e, question mark, and weight is W. Okay, so these are two things that we need to calculate. Let's see, did we miss something here? So we convert decagrams to kilograms. Do we need to convert centimeters to meters? Always. So you need to have proper measuring units. So extension must be in meters, mass must be in kilograms. So how you can convert these centimeters to meters? So you need to divide with 100. So in this case, this will be basically 0.02. So when you divide 2 with 100, that is 0.02 meters. You can check yourself. So from meter to decimeter is 10, and from decimeter to centimeter is 10. So between meter and centimeter is 100. So if you multiply this with 100, you get 2. So now we have every conversion. The next step, we need to write down the formulas. So formula for elastic force is equal spring constant, which is K, times E, which is extension. Then the formula for weight is mass, which is small m, times small g. Small g is gravitational field strength. Because I didn't mention this task any other planet or something, so you should assume that you are on the planet Earth. Small g for planet Earth, we will round it, and it's 10 newtons per kilogram. Now when you have all of these informations, let's see, can you do calculation? Let's start with weight. Do you have mass? You have mass. So mass is 0.1 kilogram times, do we have small g? We have small g. So small g is 10 newtons per kilogram. So 0.1 times 10 is 1 newton. So weight in this case is 1 newton. So one part is already done. The next step, elastic force. Can we calculate elastic force? Do we have spring constant? Yes, we have. Do we have extension? Yes, we have. So in this case, let's start. Spring constant is 100 newtons. So 100 newtons per meter times extension is 0.02 meters, which give us 100 times 0.02 is basically 2 newtons. So the answer is 2 newtons elastic force, and weight is 1 newton. So in this case, if weight is 1 newton, so weight is pulling down the spring, and elastic force is acting in opposite direction, so you can actually observe here what is going on. I hope this video will help you. I hope that you enjoy. So that's all. Bye bye.